Bugatti built the Chiron to clear noise regulations across every market on Earth, and that engineering compromise cost the W16 engine the sound it was always capable of making. For years, anyone who has actually heard a Chiron at full throttle has sensed that something is being held back. The mechanical reality of 16 cylinders, 4 turbochargers, and 1,500 horsepower spinning to 6,700 RPM should produce something more visceral than what exits those exhaust tips in factory trim. Bugatti's engineers knew it. Every driver who has pushed these cars to the edge has known it, and Valvetronic just started doing something about it. The custom exhaust system they're fabricating for Matt Armstrong and FXG's Bugatti Chiron rebuild is unlike anything that has ever been purpose-built for this engine, and the engineering methodology behind it is worth understanding in full. The work underway at Valvetronic's fabrication shop isn't a modified factory component or a bolt-on performance replacement. It's a 2 to 6 double X-pipe system being engineered completely from scratch, with the original muffler casings serving as a dimensional reference point while every internal flow constraint and regulatory compromise that Bugatti worked under gets discarded entirely. 6 individual outlets exit a layout built around precision-fabricated merge collectors and X-pipe junctions, positioned with real engineering attention at every stage. Every complex junction is being templated using 3D printing before any metal gets welded. The lead fabricator at Valvetronic delivered the objective plainly when he told Matt and Alex what's coming. They're going to crank up the sound big time. Given what the W16 is capable of producing and what Bugatti's factory system was required to suppress, that's a commitment backed by serious fabrication intent. This exhaust project is one component of a broader rebuild that has placed Bugatti's corporate position on independent automotive restoration in an increasingly difficult spot. When Matt Armstrong began work on this crashed Chiron, a Bugatti representative made a public statement characterizing independent rebuilds of cars like this one as inappropriate and potentially dangerous, stating plainly that projects undertaken without factory involvement shouldn't be attempted at all. The company's position was that without their engineering support and component supply, this work had no legitimate basis for proceeding. What that position didn't account for was a builder who would meet every refused part request by fabricating a replacement from scratch using modern manufacturing technology and specialist knowledge that doesn't require a manufacturer's cooperation to produce results that hold up technically. The gearbox bracket got CNC machined from billet aluminum, with design improvements over Bugatti's original cast unit built into the machined version along the way. 4 radiators are currently with specialists in the UK for assessment and repair. The front aluminum structure is being laser scanned and CNC fabricated from raw material, matching the original geometry without a single Bugatti-supplied component entering the process. And now the exhaust system is being purpose-built by Valvetronic, a fabricator whose body of work spans turbocharged performance applications, supercharged builds, and high-revving naturally aspirated configurations across a range of serious performance platforms. Every component in this progression came from outside Bugatti's supply network. None required Bugatti's authorization, and none have suffered for the absence of factory involvement. Understanding why the exhaust specifically demands this level of precision engineering means understanding what the W16 is managing internally on every combustion cycle. 4 turbochargers feed into a single exhaust path, which means gases from all 4 turbos must merge, pass through X-pipe junctions calibrated to balance back pressure against flow across the full RPM range, and then divide into 6 individual outlets, all while maintaining precise scavenging characteristics that determine how efficiently the engine evacuates combustion gases at every operating point. Back pressure calculations off by any meaningful margin, and the engine loses power across the range. Acoustic geometry wrong, and the exhaust note degrades from something engineered and intentional into something that simply happens to be loud. Junction positioning off, and the pressure pulses from 4 turbos simultaneously feeding into shared collectors create turbulence that destroys the note entirely, converting what should be layered and mechanical into something that sounds unresolved and accidental rather than designed. Valvetronic's lead fabricator described what they're working on without understatement. This is going to be a wild fabrication project that holds up under any serious technical examination. The W16 operates at a thermal and mechanical intensity that places demands on every exhaust component far beyond what a turbocharged 4-cylinder or a supercharged V8 would generate in typical performance applications. Extreme heat cycling stresses every weld and joint through thousands of repeated heat-up and cool-down cycles over the engine's service life. Extreme vibration from the engine and the exhaust gas pulses works continuously at materials and their connections. Extreme pressure pulses from 4 turbos firing into shared junctions test the structural integrity of every merge point under conditions that most fabricated exhaust systems will never encounter across their entire service life. The 3D printed templates Valvetronic is using to fixture every junction before fabrication begins aren't a production novelty, they're a direct and deliberate response to those conditions. Every collector and merge point gets positioned correctly and held with precision before any weld gets laid down, eliminating the stress risers at weld joints that lead to crack formation under sustained hard use at extreme thermal and mechanical loads. That discipline, templating and fixturing before fabricating, is what separates engineering from approximation when the application genuinely demands it. Community reaction to the exhaust reveals split into identifiable camps almost as soon as the images appeared, and both camps raised arguments worth taking seriously. The first group looked at the hand-fabricated titanium construction in the build photos, the precision weld geometry visible at the X-pipe junctions, the shaped merge collectors built to the specific flow requirements of this engine in this car, and described it as pure artwork. That reaction is accurate in a way that goes beyond surface-level appreciation. What Valvetronic is building is a one-of-one system designed entirely without factory input for the only Bugatti Chiron Persport in existence currently undergoing an independent rebuild. The engineering quality visible in the components carries an aesthetic dimension that comes from parts built to perform at an extreme level rather than parts built to satisfy a production line's cost and schedule requirements. The second camp pushed back directly. One commenter predicted the system would fail within a month, arguing that without Bugatti's proprietary thermal management data and real-world durability testing under W16 operating conditions, no independent fabricator could build something capable of surviving sustained hard use. The concern sounds credible on the surface and deserves a real response. Valvetronic builds exhaust systems for turbocharged engines, supercharged engines, and high-revving naturally aspirated configurations, producing meaningful power across many platforms. Material selection calibrated for heat tolerance and structural behavior at operating temperature, wall thickness for the specific pressure and vibration loads of the application, support bracketry designed to prevent vibration-induced fatigue failure over time, joint geometry accounting for thermal expansion through repeated cycling. None of these require Bugatti's internal engineering documentation to execute correctly. The fundamental physics governing exhaust durability apply to the W16 the same way they apply to every other engine, at higher intensity but under the same principles. Valvetronic's use of precision fixtures and templating before any fabrication begins is direct evidence of a methodical and disciplined approach. The W16 is a uniquely demanding application, and they're treating it as exactly that. A third line of criticism dismissed Valvetronic's reputation in performance exhaust fabrication, arguing that their standing exists only because noise regulations in heavily restricted markets make any aftermarket system sound dramatically better than stock simply by comparison, and that in less regulated environments they produce nothing genuinely superior. That argument fundamentally misreads what Valvetronic specializes in. Volume is the simple part of exhaust engineering, and any fabricator with adequate equipment can make an exhaust louder, delivering a specific acoustic character at idle, a distinctly different character under partial throttle, and something entirely different again at wide-open throttle. That's engineering. It requires correctly positioned junctions, properly shaped collectors, tuned outlet geometry, and a working understanding of how those elements interact acoustically across the full operating range. The layered, intentional sound signature that results is exactly what the Chiron's W16 has always been capable of producing, and exactly what Bugatti's regulatory compliance requirements compelled them to hold back. Factory exhaust systems on hypercars carry a comprehensive set of constraints built in from the earliest engineering drawings. Noise tests across Europe, the United States, and every other market with strict homologation requirements establish hard upper limits on what the system can produce. Buyer expectations for refinement alongside performance add another layer of targets. Production durability across the full range of conditions and driving styles that owners generate adds further requirements on top of those. Bugatti's engineers spent considerable resources developing the Chiron's exhaust note and then deliberately restrained it to satisfy all of those requirements simultaneously, and the result is a 1,500 horsepower, 16-cylinder engine that at full throttle sounds noticeably quieter than its hardware suggests it should be capable of producing. Valvetronic's 2-to-6 double X-pipe system with 6 outlets operates under none of those constraints. No noise test targets, no multi-market regulatory requirements, no refinement filter positioned between the W16 and the air outside the car. Just a system designed from the ground up to extract the acoustic output this engine has always been holding in reserve, and that no factory version was ever permitted to deliver. What that sound actually produces when all constraints get removed entirely remains the most anticipated moment of this entire rebuild. Valvetronic's fabricator told Matt and Alex directly they're going to crank up the sound big time, given 1,500 horsepower feeding through a 2-to-6 double X pipe into 6 outlets designed specifically to unlock rather than restrain what the W16 produces. That's a commitment with real engineering behind every word of it. While exhaust fabrication continues, the broader rebuild keeps moving across multiple work streams simultaneously. Bob is working through all 4 radiators in the UK. The front aluminum structure is being prepped for CNC fabrication. The gearbox bracket is already finished and complete. And the next major decision point sits directly ahead, the gearbox assessment, which carries more consequence than almost any other remaining milestone in this project. Cracks in the transmission casing have been a concern since early in this rebuild, and the upcoming inspection will determine whether the damage is cosmetic or structural. Cosmetic damage keeps the project on its current trajectory. Structural failure changes the entire calculation because sourcing a W16 transmission from outside Bugatti's parts network carries no obvious solution and no predictable time frame attached to it. Every challenge this build has encountered has eventually produced a path forward, but a compromised gearbox casing would test that pattern more seriously than anything the project has faced yet. And the outcome of that assessment will shape the timeline and the budget in ways that affect every other workstream currently in progress. What this build represents beyond one crashed hypercar being returned to operation matters for independent automotive restoration more broadly. CNC machining from billet, laser scanning for dimensional accuracy, 3D printing for precision fixturing and template work. These manufacturing technologies place independent builders in a position to produce components that meet or exceed factory specifications without factory cooperation of any kind. Bugatti's public statement was that this project shouldn't be attempted. Matt's ongoing answer has been to attempt it anyway, working component by component, at a standard of engineering that makes the original objection look progressively less credible, with every finished part installed and every challenge solved without manufacturer assistance. When the W16 fires up for the first time with the Valvetronic system in place, 1,500 horsepower feeding through a 2-to-6 double X pipe into 6 outlets built to unlock what this engine has been holding back since the day it left the factory, that moment is going to stand as one of the most significant sounds this entire project has produced. The skeptics gave it a month before failure. The people who called it artwork understood what they were looking at. Valvetronic is building the system they said they would build, and the sound that exits those 6 outlets is going to make the argument for them more effectively than any statement could. The gearbox assessment comes next. What it finds will determine what the path forward looks like from here.